Have you ever felt like you're just drowning in data? Trying to keep track of tons of different variables or names or scores in your code? Well, today we're going to throw you a lifeline. It's one of Python's most powerful tools for conquering that chaos, the list. And don't worry about the jargon, just think of it as your new go-to super container for getting all your info organized.
So here's what we're going to cover. We'll start with a problem we all face, data overload, and see how Python's list is the perfect answer. Then we're getting hands-on. We'll see how to grab and change items, unlock some amazing list superpowers, peek at a few advanced tricks, and finally, see how this becomes your new favorite tool in your programming toolbox.
Okay, let's just dive right in with a situation that every single programmer hits sooner or later. We've got a whole bunch of related stuff, and we need a way to handle it that won't make us pull our hair out. So let me ask you straight up. Picture this. You've got a class of 30 students. How in the world would you manage all of their test scores inside your code? Just take a second. What's the very first approach that pops in your head?
You'd probably be tempted to do something like this, right? Just create a new variable for every single score. But you can see where this is going. It gets out of control fast. This is a total coding nightmare. It's not just messy, it's a pain to work with. I mean, imagine trying to find the class average. You'd have to add up 30 separate variables. There has to be a better way.
And you're right, there absolutely is. Smart programmers live by this really simple but powerful rule, DRY. It stands for don't repeat yourself. The whole idea is to write clean, efficient code and avoid doing the same thing over and over. And that mess of variables we just saw, that is a perfect example of what DRY tells us not to do.
So how do we follow the DRY principle and fix our data mess? Well, Python has this brilliant, super elegant solution, the list. This is the tool that's going to bring order to all that chaos. So, what exactly is a list? Well, it's an ordered, mutable collection of items. Ordered just means the items stay in the exact sequence you put them in. And mutable? That's a fancy word. That means you can change it, add things, remove things, anytime you want. The best way to think about it is like a single container, kind of like a bookshelf with numbered slots, perfect for holding all your related items together. Now, you might also hear about something in Python called a tuple. The main difference you need to know is that lists are mutable. You can change them. But tuples are immutable. You can't. You'd use a tuple for something that should never, ever change. But for our list of scores, which might grow or change, that flexibility is exactly why we want a list. All right, so we have our container, but how do we actually get stuff out of it or swap items around? Well, that's where something called indexing comes in. Okay. Here's a really important thing to get about Python lists. They use what's called zero-based indexing. Look at the top row. The very first item, P, isn't at position 1, it's at position 0. That's a big one to remember. But check this out. The bottom row shows a really cool trick. You can also count from the back. Index -1 is always the last item, -2 is the second to last, and so on. Super useful. The source material puts this perfectly. It says to think of the index like a map that leads directly to the element. So, index 0 is the address for the first item, index 1 is the address for the second, and so on. It's how you find exactly what you're looking for. And because lists are rootable, we can use that address to change what's there. Let's walk through this example. First, we have a list called numbers with 17 and 123. Then we target index 1, which holds 123. And we just tell it, hey, your new value is 5. And what's the result? The list is updated. It's now 17.5. It's really that simple. Okay, now for the really fun stuff. Lists aren't just for storing things. They come with a whole bunch of built-in superpowers. These are functions and methods that let you do all sorts of amazing things with your data super easily. Let's check them out. First off, you can basically ask your list questions. Want to know how many items are in it? Bam, use len. Need to find the biggest or smallest number? That's what max and min are for. Want the total sum? Sum has got your back. You can even ask, hey, is this item in there with in? Or count how many times something shows up. These save you so much time. Then you've got the methods that actually change the list. Append is your go-to for just tacking an item onto the end. Insert is more precise. It lets you put an item exactly where you want it. Remove and pop give you different ways to take things out. And sort, well, it does exactly what it sounds like, putting everything in order for you just like that.
Let's just take a quick look at append in action, because you're going to use this one constantly. It's a simple 3-step process. 1, you start with your list, here it's T. 2, You just call the dot append method right on that list and give it the new item, D. And 3, that's it. The list itself has been changed. It's a super direct and efficient way to make your list grow.
So those are the superpowers for working with one item at a time. But what if you need to work with a chunk of a list? Well, that's where we get into some more advanced but seriously useful techniques. Let's get a quick glimpse.
This technique is called slicing, and honestly, it's a total game changer. Instead of writing a complicated loop just to grab a few items, you can get a slice of the list in one clean move. Look at the table. To get the items from index 1 up to, but not including, index 3, you just write T of 1:3. You can even leave out the first number to start from the beginning, or leave out the last one to go all the way to the end. So much cleaner.
And lists play really well with other parts of Python. Say you're building a game and you need to pick a random player from a list of names. Well, you can just import the choice function from the random module, give it your list, and it'll hand you back a random item. It's a simple thing that unlocks a ton of possibilities.
All right, let's pull all of this together and circle back to where we started. Why does all of this matter so much?
Remember this big idea? DRY. Don't repeat yourself. We started this whole thing because we were trying to avoid that messy, unmanageable nightmare of creating a separate variable for all 30 of those student scores.
And here's the bottom line. Lists are that solution. They take that chaos of data and put it into one single organized container. Now, all 30 scores live in one variable, a list that you can easily access, update, sort, and analyze using all those superpowers we just talked about. It's clean, it's efficient, and it gives you so much power. And that really gets to the heart of it. Lists aren't just some abstract concept. They're a fundamental tool for building bigger, better, more interesting programs. So the real question, the one I want to leave you with, is this. Now that you have this incredible tool for organizing data, what are you going to build?